All right, guys, we're back at it. So, today we're going to start on Chapter 15, Section 1. We're going to be moving rather quickly, so make sure you're watching these videos and acquiring as much of this information as possible for the test. Final test of the year. So anyway, we're going to talk about today 15.1, trigonometric functions of acute angles. Right triangle-based definitions of the trigonometric functions, cofunctions, trigonometric function values of special angles. Okay, so first of all, let's get some definitions out of the way here. Right triangle-based definitions of trig functions. For any acute angle A in standard position, the sine of A is equal to the side opposite over the hypotenuse. In this drawing, this would be y over r. And the cosecant of A is equal to r over y. So the hypotenuse over the side opposite. So that would be the reciprocal. So the thing I try to get students to understand, we teach them a little code word in geometry called SOHCAHTOA. And so sine is the opposite over the hypotenuse. So since this is the angle here, y is the opposite, r is the hypotenuse, and that way we know what we're dealing with. Since sine and cosecant are reciprocals, okay, so that's what you want to keep that in mind. Cosecant matches up with sine. Cosine of A is equal to the adjacent over the hypotenuse. So we use the code word CAH, C-A-H. The secant of A is the reciprocal of that, so that would be the hypotenuse over the side adjacent. Now I know what you might be thinking. Why wouldn't they put secant with sine and cosecant with cosine? And I really don't know why. And it's really not important. Okay? Just keeping in mind that for sine it's cosecant, for cosine it's secant. Okay? So those are the reciprocals. And there are some reasons for that that we'll get into as we move along. The tangent. So the tangent of A is the side opposite over the side adjacent. So the code word for that is TOA. T-O-A. TOA. Okay, and so the cotangent is the reciprocal of that. So the cotangent would be the adjacent over the opposite. The adjacent over the opposite. Okay. So here we go on the first example. Find the trig functions of an acute angle. Find the sine, cosine, and tangent values for angles A and B. So we're going to say sine of A. So when we do this, I'm going to do these in two different colors here. So this is angle A. So I'm going to label everything according in black with angle A. So this is the opposite. This is the adjacent. And this is the hypotenuse. Right? The hypotenuse never changes. So we want the sine of A, cosine of A, and the tangent of A. Okay, so the opposite over the hypotenuse, the sine of A. So, S-O-H, sine over opposite over hypotenuse. So that would be 7/25. The cosine of A is 24/25. And the tangent of A is 7/24. Now let's do this in a little different color. We'll use green. So now for B, well, the opposite is the former adjacent, and the adjacent is the former opposite. And the hypotenuse remains the same because that doesn't change in a right triangle. It's always across from the right angle. So let's look at the sine of B, the cosine of B, and then the tangent of B. So you're going to notice some interesting things here. So the sine of B is the opposite over the hypotenuse, which is 24, 25, 25ths. The cosine of B is the adjacent 7 over 25, and the tangent of B is 24 over 7. Now you'll maybe notice some things here. Let's take a look here. You'll notice that the sine of A is equal to the cosine of B. You'll also notice that the cosine of A is equal to the sine of B. And the last thing we would probably notice here is that these two are reciprocals. Those two tangents are reciprocals. So, what can we derive from that? Well, let's not derive anything. Let's erase everything. The first thing, okay, so let's go through these answers here. Okay, so sine of A, cosine of A, tangent A, right? So we talked about those. And sine B, cosine B, tangent B. All right. So the sine of A is equal to the cosine of 90 minus A. Okay, because angle A and angle B both have to add up to 90. All three angles have to add up to 180 in a triangle. And since one of them's a right angle, that means the other two remaining angles, the acute angles, are both complementary. They have to add up to 90. So the sine of A is equal to the cosine of 90 minus A. The tangent of A is equal to the cotangent of 90 minus A. And the secant of A is equal to the cosecant of 90 minus A. The cosecant of A is equal to the secant of 90 minus A. The cosine of A is equal to the sine of 90 minus A. And the cotangent of A is equal to the tangent of 90 minus A. So these are all related to each other. All right, now, so write each function in terms of its cofunction. Okay, so if you remember, the cosine of 52 is equal to the sine of 90 minus 52. So that would be the function, the cofunction. So 90 minus 52 is 38. So the sine of 38 would be the cofunction. The tangent of 71 would be equal to the cotangent of 90 minus 71. So that would be cotangent of 19. The secant of 24 would be equal to the cosecant of 90 minus 24, which comes out to 66, cosecant of 66 degrees. Next, find one solution for this equation. Assume all angles involved are acute angles. Again, tangent and cotangent are, those two angles have to add up to 90, right? So for this to be true again, since tangent and cotangent are cofunctions, the equation is true if the sum of the angles is 90 degrees. So 2 theta minus 18 plus theta plus 18 equals 90. 3 theta equals 90, right? The 18's cancel. 2 theta plus 1 theta equals 3 theta. Therefore, theta is equal to 30. Okay. Next concept is increasing and decreasing functions. If you look at this drawing here, as a increases, y increases, and x decreases, right? So as that opens up, y is going to get bigger, but x is going to get shorter because r is going to stay constant. All right. So since a increases, y increases, and x increases, since r is fixed, sine of a increases, cosecant of a decreases. Okay, we'll take the reciprocal of that. Okay, so as that increases, then the cosecant must decrease because it's fractional. As the cosine of a decreases, the secant of a increases. As the tangent of a increases, the cotangent of a decreases. Now you might be wondering, why does the cosine of a decrease? Well, if you'll notice, x gets shorter. So as a gets bigger, x gets shorter, and that is going to decrease, right, the cosine. All right. So we want to determine whether each statement is true or false. The sine of 21 is greater than the sine of 18. Well, we saw earlier that as the angle gets bigger, the sine increases. So as the interval from 0 to 90, as the angle increases, so does the sine of the angle, which makes the sine of 21 degrees greater than the sine of 18 degrees, a true statement. Okay, cosine of 49 is less than or equal to cosine of 56. So as the interval from 0 to 90 increases, the cosine of the angle decreases, which makes the cosine of 49 less than or equal to the cosine of 56, a false statement. Okay, now we want to talk about 30, 60, 90 triangles. So in those triangles, if we were to bisect an angle and just drop down here, we would end up with a right angle, and each of these are 30 degrees. So that's what we call a 30, 60, 90 right triangle. And there it is in this drawing here. Now, the length of the sides, you'll notice each of these pieces here, the short side, the short leg, how do we know it's the short? Well, it's across from the 30-degree angle. So the shortest leg is 1 in this drawing. The hypotenuse, right? So this is, I'm going to put an S here, short leg. The hypotenuse is here, that's 2. And then X is the long leg. So now we're going to use the Pythagorean theorem to solve for x. So 2 squared equals 1 squared plus x squared. 4 equals 1 plus x squared. 3 is equal to x squared. Therefore, x is equal to the square root of 3. So 6 trig function values for a 60-degree angle. Okay, so we have sine, cosine, tangent, cosecant, secant, cotangent. So the sine is the opposite over the hypotenuse. So the sine of 60 is the square root of 3 over 2. Cosine of 60 is 1 over 2. The tangent of 60 is the square root of 3 over 1, or just the square root of 3. Cotangent is the side adjacent over the side opposite, right? So instead of opposite over adjacent, it's adjacent over opposite, which is 1 over the square root of 3, which we must rationalize, and we get square root of 3 over 3. The secant of 60 is the hypotenuse over the adjacent, which is 2 over 1, which is equal to 2. And the cosecant is the hypotenuse over the side opposite, which is 2 over square root of 3, which we must rationalize, becomes 2 square root of 3 over 3. Okay, now we want to do a 45, 45, 90 right triangle. This is done by taking and drawing a diagonal of a square. and we end up cutting the square in half and end up with two 45-degree angles and a right angle. So this is an isosceles right triangle, which is 1 squared plus 1 squared equals r squared, and then we end up with 2 equals r squared. So r is equal to the square root of 2. So the sine of 45 is the square root of 2 over 2. The cosine of 45 is the square root of 2 over 2. The tangent of 45 is 1 over 1, which is 1. Cotangent, 1 over 1, which is 1. Secant of 45 is the square root of 2. And then the cosecant is also the square root of 2. So with these special angles, we end up with some very interesting patterns. So the sine of, we start with theta, the sine is 1/2, cosine is square root of 3 over 2, tangent square root of 3 over 3, cotangent square root of 3, cosecant 2 square root of 3 over 3, and the secant is 2 square root of 3 over 3, and then the cosecant is 2. Again, as we've pointed out, we can derive all of these from our knowledge of 30, 60, 90 right triangles. 45, 45, 90s. Again, sine and cosine are going to be equal because it's isosceles. So it's square root of 2 over 2. Tangent and cotangent are both 1. Secant and cosecant are square root of 2. And then with 60-degree angles, and here's something you may find rather interesting. Maybe not, but I do, right? Those are identical. These are identical here. Reciprocals, right? Those are identical. And that situation there, okay? So, because 30 and 60 are complementary angles, this is what happens with that.